got to be pretty late there, Mike, in New Zealand.
Yes, it is. It's 2 a.m. in the morning down here, and it's nice and chilly too. It's about 3 degrees down here at the moment. So got the heater blasting behind me, so it's keeping warm.
That's awesome. So you're going to give us your clinic is a introduction to Arduinos.
Yes.
So I'll be quiet, turn my camera off, and we'll get going with clinic number one. Only 9 minutes behind schedule. So over to you, Mike.
Okay. Hi everyone. This is my first NMRA clinic that I've given, so hopefully it all goes to plan. I have a few things here that I'd like to show you before we get into the PowerPoint. What I'll be talking about today are these amazing little boards called Arduinos. I just dropped a bunch on the floor, had them all lined up. That's all right. These Arduinos, and what I've got right in front of me here is a little development board. This here is the Arduino Uno, which I'll go into a little bit more detail. Nothing too technical, just to what it is, roughly what it can do, etc. And this here is what we call a breadboard for development, and a little power pack to come in and things like that. So those are a couple of the things that I'll talk about, and also mention quickly some things about some relays, which are basically just power switches on and offs. Show you how to make yourself around $50, or describe, go through the basics, and then give you a handout on how you can make yourself a $50 little DCC pack that will run your layout or run the testing track on your workbench as I do. So we'll get into my PowerPoint now. So hopefully this transition works nicely. So I'm going to share my screen with you all. So into my talk, share. So I'm guessing that is working, everyone.
Yeah, everyone can see your presentation.
Nice, thank you. That's all good. So we're into this. So this is the very first introduction to Arduino. Hopefully it won't be too technical. I've tried hard to pull it back because I'm a web developer from down in New Zealand. I model BNSF, the Santa Fe BNSF transition era from about 95 through to about just a 10-year period around that. So, and I model that, and I love weathering, building buildings, and also Arduino and electronics is something that I've got a passion for as well at the moment. So it's something that's fun and exciting because you never know what you're going to discover, and you meet so many people that are interested in this thing, and you hear so much about it, and so many little cool things that you can do to animate your layout to make it look a lot nicer. So slide one. Part one, what is an Arduino? Just an overview of what the boards are. In front of you there is an Arduino Uno, which is one of my go-to boards when I'm prototyping up something. What is an Arduino? An Arduino is an open source electronics platform based on easy to use hardware and software. Open source means that basically this board was made in Italy, and they basically gave the design specs to the world. So now the Chinese and lots of the manufacturers of electronics have picked up this board, and they're cheap. They're cheap, and the quality is quite good too. So they're $3 to $5 a pop from the right retailer. So there's not a huge outlay to get yourself into an Arduino. And then the next little bit that I'll go into is I'll show you an Arduino boards are able to read inputs. They can light an LED, do something when a button is pushed or toggled, activate a servo to move a point to send a train up another route on a rail, take inputs from sensors to tell me where my train is. Basically, you can tell your board what to do by sending a set of instructions to the microcontroller on the board. To do so, you use the Arduino programming language based on language, which is basically you plug some wires into some pins on your Arduino and you get things in and out. Don't be too scared by the Arduino software and the IDE, and because it's not that scary. If you can send an email and things, just don't get too scared. But you may be thinking after that little bit, what the heck's Mike talking about, and feel a bit lost if you're new to this, the world of Arduinos. Well, don't worry. Try not to be too technical, as I mentioned before, but hopefully give you some good ideas and where to start. Get your mind tinkering, get your imagineering going, and the world is limitless. Part 2, Arduino boards. What are they? What are some of the types of different Arduino boards? On the right-hand side there, you can see the big daddy of the Arduino boards, which is the Mega. Basically, the Mega has a slightly faster processor, a bit more capacity on storage, etc., and a truckload more pins than the other Arduinos have, which means you can plug more devices directly into it. But with some smarts, you don't need to use a lot of the pins these days. You can get away with doing lots of things on your Arduino without plugging in too many pins. The Arduino Uno, the green one in the middle there, is one of my favorite go-to boards. You have a USB power, USB in for programming it and powering small devices like LEDs, etc. You have a little power pack on the side there that you can plug in your little square power pack into, etc. This has a bunch of pins, does the same as the Mega basically, just not quite as fast. And then down below is the Nano. The Nano is a smaller version, which means the footprint's smaller. So if you've got a tiny space under your layout or a tiny space in your panel, this fits nicely into that area. And I'll go into that in a bit more detail further down on how you get the wires onto that. And then on the left-hand side there, you can see the newer versions of some of these boards, which have a Wi-Fi built in. This is one of the cool things with the newer boards is you have Wi-Fi on it, and you can then talk across a distance without running lots of cables. So instead of having to run 2 meters of 6 foot of cable, you think in your yard, you run a foot or so of cable to your points and your sensors and your signals, and then the Wi-Fi will send back to your panel, and away you go from there. How do I power my Arduino? Well, that's a good question. You can use multitudes of things. You can use a thing like a 9-volt battery to power your Arduino if you wanted to. So basically, you put 9 volts in, 5 to 12 volts in, and you basically the board will run. So it doesn't take a lot of power to run them. Some of the Nanos will now run on, and the smaller ones will run on 3.3 volts, but 5 volts is a good voltage to run towards to run into your Arduino to power that. And if you've got lots of devices running off it, you'd run an external accessories power off the side. And then we'll get into what modeling projects can I build on my layout and my dioramas with my Arduino. We'll start first with the Arduino Uno. This is a classic one, which has the bigger chip in the middle. The slightly newer ones have a little integrated circuit, which is a bit flatter. But basically, that's what the Arduino looks like. This is a great starter board, as you see, because you have those little pins at the top and the bottom, little rails at the top and the bottom where you can plug in your little cables without any soldering, etc. The connector pins actually, and the size of this make it a great starting board because you can actually see the numbers quite easily, etc. You don't need to. It's not too small that you can't pick it up and handle it, and it's a bit more rigid and solid, etc. So that's the basic Arduino board there. You can power it by the USB, and that's how you program it, how you get the commands into this microcontroller. It's not a computer as such. It's a microcontroller, so you basically give it some commands and you tell it to, if I wanted it to turn on an LED on and off or something like that, you would tell it on pin 6 to turn me on and off, etc. And now we get to the Arduino Mega. The Mega is the big daddy. He's got loads of pins. So if you need lots and lots of pins, you go for a Mega. They're a little bit more expensive, but they're a little bit faster. But the speed for running your model trains, etc., is not needed that much because under a second to half a second or so to move a signal from one place to another is plenty long enough for your trains. The main difference is the wiring pins, as I mentioned. There's a truckload. There's 50 odd on the Mega, and there's only 30 odd on the 13 on the Uno. Then we get into my favorite little board for building things because the footprint's so small, is a little Nano. Even though it is small, it has the same number of pins as the Uno, and it's about the same speed as the Uno. You don't really notice it in your model trains for what you'll probably be doing with it when you first use it. You may be thinking, how the heck would I actually get the wires, get the power, get the outputs, the inputs, the outputs into little Uno. And one way is to use one of the little boards you can buy. This particular board I brought out of China from AliExpress, and it cost me I think it was $1.20 or something like that. And basically you plug the Uno, you push the Uno straight on top, and it gives you all the pins get pushed into normal little screw-in wires. So you can put your little wires into the side, and you get your inputs and your outputs that way. You've got your USB on top, so you can power it the same as the Uno, but the footprint on that is nice and small. There's many other boards that you could use as well that do the similar things, all sorts of different things. Next, we get into how I go about powering my Arduino. Well, as you can see in this little diagram, this little fritzing diagram here, is down the bottom you've got the Uno, and basically we're plugging in just a little brick that is 12 volts, just a 12-volt brick, and you've probably got a bunch of those floating around somewhere, and it needs and about an amp's a nice amount of power for that. And you plug that in, and the Uno takes care of controlling your power, dropping your power down to the 5 volts that you need to run most things or thereabouts. And then if you've got something that's a little larger that you're running off the side, say you want to run 5 or 6 servos, or you want to run some solenoids or some stepper motors to power, say a stepper motor to power a turntable or something like that, you might power in through power it separately through your prototyping board or your little circuit board, etc. So you'd run the power that runs your accessories. So you work out what your accessories need and you power it that way. There, of course. Okay, now to get into the fun stuff. What projects could I build with my Arduino? Now the mind starts going, so what can I do with an Arduino? An Arduino is good for turning things on and off. An Arduino is good for reading sensors. Now you might be thinking, what can I do by turning things on and off? Well, turning lights on and off could be signaling, turning lights on and off in a building. Sensors to trigger, to send a signal back to the Arduino, then the Arduino sends a signal back to the signal on the track, and you can turn the LED from red to green as you go through that, from green to red or red to green as you go through a section on your layout, or you could send something back to a computer, to the command controller, to say the train has passed through this area successfully. Basically, you're only limited by your imagination when it comes to the Arduino. It's like I've wired my model railway up. I've got my engines running on my DCC or my DC. They make a nice noise, but my scenery looks fairly static. What can I add to my scenery, to my scenes, to make the animation, just to give it a little bit more interest, to catch the eye of the passer, of the person looking and enjoying your layout? Well, one thing you could do is you could simulate an arc welder. This is taken from off the net. I'm not sure who I sourced it from, but it's a no-scale representation of an arc welder. I've built a couple of these for guys. Basically, you use how would you build this? Well, you take something like an Arduino Nano, a couple of LEDs. You'd use 2 LEDs because you have one turn on and one turn off. And the LEDs, basically, you want to simulate the flicker. Now, an Arduino is a really useful tool for doing this, because being able to turn something on and then turn something off is what a microcontroller does, and that's what an Arduino is. You can tell it to, for say 2 seconds leave one LED on, and 1 second turn the other LED off. So that one stays on 2, the other one stays on 1, and you end up in time, until you get your timing right. You can use 2 or 3 LEDs, but two works well, and you get your timings to where you want them to be, and you end up with a little flash. And then you could put another command in there to say, after 20 seconds, stop the lights for a minute or so, as though the welder's gone and welded something, and then he's gone away and come back. And you just need a couple of resistors in the circuit, so you could behind the LEDs, just so you get the voltage, just so you get the light just where you think it should be for where the scene is on your layout. But if you had those 4 guys standing there without the little Arduino flashing those lights like an arc welder, that scene wouldn't look half as interesting as with the LEDs. You're probably going to look a lot the visitors are going to look a lot closer at your layout and take note that, oh look, there's a scene there. Oh, are they welding? Why are they welding that rail? Are they cutting it in half? Are they welding it together? What's the story behind that little scene? And there's a little bit of soldering involved, which is normal. Most of you have probably put some droppers on a track, wired that through, so it's not much more soldering than that. Then you mount it on your layout and you get set up. I will put this in the a link to building one of these in the document that I'll supply the next day or so as well. So you're able to go and get the code, put it on an Arduino, and make yourself a little arc welder and put it somewhere on your layout. Another thing you could do is you've got a really cool building sitting sort of in the backgroundish or somewhere in there, and you want to just highlight that little area near the back so people actually look over there at all the good work you've done. You've put some interiors in, etc. You could put some shadows in some windows and have some lights turn on and off. This was something that I saw in MRH magazine. They did this and it was very, very cool. I've actually got one wired into one of my buildings as well. Slightly different colored LEDs, sort of purple hazy ones and some light ones, and you can paint the windows slightly different colors and things like that. But something you could do is you could put some timers on your LEDs. So you could have 6-8 timers, 6 little LEDs into your Arduino, and your Arduino, you can tell your Arduino, leave number 1 on for 10 seconds, number 2 on for 5 minutes, and turn them on and off. Maybe you could you can randomize them. And in the older before Arduinos were around, you'd have to use little chips like 555 timers, if anyone remembers those, all these chips and lines and things like that to try and make your timings work, etc. This way each LED is basically controlled off the Arduino, and a little bit of code says LED 1 stays on for this long, LED 2 might come on and it might flicker. So you might set one to turn on and off quite fast, like the bulb's actually a little bit flickery when it first comes on, then it goes on solid, then it turns off, and then after an amount of time you can tell it to turn back on and repeat that same little sequence. Or you could have 5 or 6 different sequences in there and randomize them. So when you look at the building, one day the top left light turns on and then the other lights turn on. Sometimes they won't turn on at all. They'll turn on and off, like people are actually interacting in like the building's full of humans actually doing something. And then you could even wire in a little sound card onto that. There's a little Arduino MP3 player where you can put some noises and some sounds. You could have a crane sound in the background randomly going off. You could have some people talking to each other, some little chitter chatter, doors opening or closing, just little sounds, a little phone going off every now and then. Just randomize those sounds coming through as well, just to give your little scene a bit of life, make it more interesting. Now we get into something that everyone probably knows about a little bit, and we get some track signaling going. So the track signaling is there. Lots of people want it and like it, and it's very cool to have track signaling, especially if you've got 2 or 3, 4 or more operators on your layout. Track signaling becomes a big go-to thing where you drive along, you know that orange, you got to slow down, etc., depending on which part of the world that you're actually modeling, etc. So track signaling is done relatively easily with a not easily, but is very achievable with a Nano and an Arduino, and using a Nano on a what they call a prototyping board, which is perfect for model railroading needs. Or you can get circuits designed if you get a circuit that you really, really like, etc. But that's getting a bit more advanced. But back to this little prototyping board, those boards cost around $5 or a bit around $5 to $10, if that. And you put your Nano on there, and you can have your signals going off it. You have some wires coming in, that those 4 wires at the top power, etc., and a couple of communication lines in the middle there that talk back to your sensoring board. So you have your sensors in your layout, you come through, or they could be just wired to your towards your switches, etc. And then they send a signal down to say, maybe I'm in this block here, make signal number 1 on the left go green, number 2 go orange, and the third one go red. And then you get through and you can change the order depending on what signal you send to the signal themselves. And this gets really, really interesting when you start getting into that. And the wiring gets very tidy as well. You haven't got these long runs of, you don't have to have long runs of wire. You can imagine if you have something like this and you put a little wireless module on it, you can have that under your layout where you've got these 3 or 4 signals in your yard or before your yard somewhere, and that talks back to the home to the sensor nano, and you don't have a long run of wires, which the sensor taking one maybe 8, 10, 15 feet away from where your signals actually are, and you haven't got these long runs of wire, and you know that when those signals aren't working, you know it's that, and it's only a short piece of wire that you have to actually go in under the layout and diagnose. It's not running from here all the way along and tracing it all the way back to see where it may have come apart or broken, because a lot of the time your wires will run and then you'll have a join and then you have another join further down the track. Another very cost-effective way that Arduinos help or can be used is when you start using servos. We all know how much the tortoise motors cost, and they work really, really well, the tortoise motors, but the size of them sometimes it's just a little bit too big to fit them in your layout, because the size of them is quite bulky. But you get those little blue things there, those little servos, they're the same little things that you would have had in your little radio control cars when you're younger, or your kids have got, that turn the front wheels left and right or drive your tanks and things like that. They're similar to those, and those servos cost a whole $1 each, and the footprint of them is small. You can set them like this, or you can set them on the side. You can put them in a building and you can have it pull the point backwards and forwards, etc., and use the Uno to drive those. Or if you get a little bit further down, a bit more advanced, you get a little driver where you can not use up all your pins, but you get these little boards that will allow you to run 16 servos off one Uno or more off one board. So you get a little bit more advanced. So if you've got a big yard, you don't have to worry that, oh, I'm going to have to put in a whole bunch of these Unos. No, you get a bit smarter and a bit more advanced than when you first begun, where you're running 4 things off there. You run these little boards that will let you run 16, 32, etc., and you can block them up together. So you've got 16, 18 points or power blocks, etc., because that you need to move or you need to turn on and off in your yard. You have these little boards are amazing because you get 16 little wires all grouped together, nice and easy to diagnose. You can pull, one doesn't work, you just take out the pin and away you go, and you see, okay, or you plug it into another one and that goes, and you there. But you need to put the code on your layout. Those blue servos are 9G. They're called a 9G servo, a little blue thing. And on eBay, you can pick them up anywhere from, I'll pick them up when if you buy them in bulk, they cost $1.50, $2 a servo, and up to $5 a servo, depending where you're sourcing them from, by the time you pay postage, etc. So if you want to try them out, and the Uno together with that, you probably spend yourself $20, if that, and you can get started and you can have a play, and you'll be away and running and laughing and giving it a test to see if it's what you want. You can set the speed as well, so you can have it slow motion as much as you like, or you can have it go at a faster speed if you want it to go faster. So you can set the speed and the throw, etc., yourself. So there's a lot of possibilities with these, and they fit in really tight spaces as well. Here's another servo. There's something that we've designed for my model railway club here in Auckland, called the Western Districts Model Railway Club. we have a number of points that have been down for 30 plus years, and some of them have just worn out and just been used that much that they've worn themselves out. So as we replace them, we've been putting servos on. So we've done 1 yard where we've upgraded the wiring, etc. And we've come up with this fairly nifty little design that we used from someone else on the net. It's just a piece of aluminium channeling that you get from the local hardware shop. And we've run some piano wire through, and this is a under the layout mount of the servo. So you can put the servo either in the channeling if you've got less space, or if you've got more space, you put it underneath. A couple of little nylon screws to hold the servo, just enough so it holds it in, a couple of big screws straight through, and some number 9 piano wire goes on, and it goes up to there. There's the same thing, but we've cut a little angle on it just so it fits in nicely, and it's mounted inside the channeling this time, so it goes in. The difference between the two is the first one. Am I coming through okay? Sorry about that, everyone.
Yeah, we can still hear you. You're fine.
I'm fine. Okay, cool. So okay, I'm not going too fast. No, that's all good. Okay.
Oh, no, you're all good. You're all good. Keep going.
I'm all good. I'm all good. Okay, yeah. This here is actually the first prototype that I built when we first started looking into servos as an alternative to the classic Pico style switch motor that you just, it goes clunk clunk. You must have heard that a lot. You throw the switch and you hear a clunk and it throws it. That work. They work a treat. They just throw the point, lock it in, and away you go. And then someone suggested we try servos and Arduinos, and I started playing and came up with this little concept with another guy. And I'm just using piano wire, which is a little bit springy, and pop the spring out of the Pico point and shove it up the hole, and away it goes. And they work a treat. They've started working really well, and they're really cost effective when you start to look at it, because those Pico points motors go for somewhere with $30 a pop, and we had to replace a bunch because we got a bunch of we had a bit of leakage at our club, and a few of them got rusty and started locking up and weren't worth fixing. So we changed a whole bunch out to these servos, and they're just working a treat. And we've got them running nice and slow now, so it's not just a throw, it's a nice little backwards and forwards, and away we go with that. So and there's many examples. I've seen people on the net, they have there's a whole bunch of 3D printable versions of mounting the servos to go with the points underneath, and they all work really, really well. But this was something that I thought of: go to the local hardware shop, buy some standard aluminium channeling, and cut it out, drill a couple of holes. And the hardest part of this whole process was drilling the 1 mil hole through the channeling and back up the other side for the piano wire. We used it for the number 9 piano wire that we used. We went with the piano wire because of the spring in it, to just so that when it came across, you could go a tiny bit further than you needed to, and it would just be enough to hold the point without it slopping. Here's something this is one of the first things that I built when I first heard about Arduinos, was DCC++. This is a full DCC system that you can build, and it will cost you around $20 to $50 depending on what you buy, excluding the Raspberry Pi that's in the silver box on the right there. So what we have here is, I have used a laptop power supply, and these are really useful little devices. You get one for 19. You get a 19-volt one, about 1.5 amps. You can buy brand new replacement ones anywhere from $1 to $5, non-branded, off the internet, off eBay or your local or Craigslist or something like that. And they are so good. And people go, "Oh, you don't really want to use one of those." And then you explain to them, well, you have an $800 to a $2,000 laptop sitting in front of you, and you plug one in every day without thinking about it. So plugging it into your train, to run your model railway, is a really good thing, because that little power supply there has a few things inside it that stop it from shorting itself out completely and things like that. It's not the you can put a fuse in the middle if you want to, but I wouldn't think so with you running 15 volts down there. So there are buck converters. The bottom left where it says 15 VDC, if you can read that, and 17 volts DC are the two buck converters. The 7 volt DC goes across to the Arduino, which is hiding under the little board that sits on top of it, the extension board. And the 15 volts DC is what I've set to run the layout. And by the time it goes through everything, you get about 14.8 volts out for my test track, which is there on the left. So, and with this system here, you basically have an Arduino, and then you have a motor driver board, which is the board sitting on top. Excuse me. But you put a couple of jumpers on. You put a couple of jumpers in, and away you go, basically. And you basically just nick one little resistor on the back side of that, and away you go. And you get a programming track and a normal running track. So if you've got a small layout, this is a really cost-effective way. Or you want, or your workbench is a little bit away from your layout, and you want to be able to program up your new locos, get the consists running together, change your CVs around a bit, maybe change the sound. This is a perfect little tool for doing that. And the I use a Raspberry Pi in my setup, and that's a little $80 to $100 computer itself, and you run a thing called Raspberry on it. But you don't need to have one of those. You've got a laptop or you've got a computer sitting around somewhere, just use one of those. Put JMRI on it, connect it to this system, turn JMRI on, and away you go. If you turn the Wi-Fi on in the JMRI with the system, you can use, and you have a smartphone, you have a wireless throttle. You don't have to sit at your computer and drive your train. You have a wireless throttle to your train, to your train then. So you can run your trains with your wireless throttle using engine driver, if that is something that you want to do, which means that you can walk around your little layout, with your DCC going and have a play. And if you're not sure about DCC and you got one loco that is DCC, this is a good introduction into DCC till you decide what system you want and whether or not you actually think DCC will be worth it for your layout. I'll also put a link into making one of these. It takes about 10, 15, maybe 20 minutes, half an hour to throw one of these, to put one of these together and get it running, and then get the DCC signal onto the track. So it's not a lot of work to get it going. It's all download a bit of software, and the longest bit is probably installing the software onto your computer and then getting it onto the Arduino. But the fun part is making little wires and things like that. And I've just put it on a piece of little ABS plastic there, just so it's a nice solid base and I can move it around if I need to and things like that as well. This is another little prototype that we've just been building because we're upgrading all the panels down the Western District. So we're still a DC club, old-fashioned DC, 30 years old. We're moving towards a DCC system over the next few years. So we're upgrading everything at the moment. I've got a bunch of those LEDs and NeoPixels, which are very cool things as well. You'll probably enjoy these. They're multicolored. You can set the color to whatever you want. You have blue, greens, reds, etc. with one light. So push the yellow button on that panel there and you'll get a yellow light. It's programmed that if you push the blue one, you get a blue light, etc. If you push one of the black ones, it'll go green on the direction that you want to go, or red where you can't go on the point, etc. So those are very, very cool. And the blue and the yellow are the power buttons, and the black ones are the little point switches. So that was I just drew that. We drew that up in Draw.io, a free program online, and just made it, printed it out, stuck it on some board, and sealed it up with some matte varnish, and it's working a treat. So that's our first prototype that we've done for this, which only went in about 2 weeks ago. So during our lockdown, we built, me and one of the other members built this up, and the push buttons and NeoPixels, etc. And here's the innards of the workings of it. At the back there, you've got you can see down the bottom, you can see very back, you can see the Nano sitting there, and you can see the panels and the buttons and the NeoPixels sitting there. NeoPixels are very cool because they have an address. You can address each one as you go through, so you can actually pick those up and know that you can send a signal back from the nano to say turn on light number 1 or light number 2 or light number 3 or 1, 2 and 3 at the same time, etc. For a future presentation, I might do something on how I actually built this panel, which is very interesting. We've used a thing called a resistor chain to in with the switches, so you can actually we just work out the voltage of each switch when it's pushed, each push button when it's pushed down, and then you know which button was pushed, so it knows which part of the code to run. In the front here, those big blue boxes are just old-fashioned relays on a circuit board. Basically, they just turn things on and off. You send a signal to them, and they turn either power on or off, or switch something on and off. The ones to the right with the capacitors on, they're the ones that are running the old-fashioned pico points. We put a capacitor on those, 2 diodes on our points motors, and away they go. And they run a treat. Now, you may be thinking, oh, that sounds very, very interesting. So what do I need to begin my Arduino journey? Well, there are several things, and one of the best things to do is spend some money. And it's not a lot of money. It's $30 to $40, and that would be a decent carriage these days, a pre-built, ready-to-run carriage. A nice hopper car from Scale Trains or somewhere like that, or Intermountain, and there's a price of probably more. They're probably worth more than this little starter pack. But in the starter pack, you'll get yourself an Arduino. You'll get what's called a breadboard there with the stripes on it, which is your development board, your prototyping board, basically. You get some of the cables that you need to start you off. There's a whole bunch of resistors and things, and they're all those little things that you need to get you started on your journey into the Arduino. And you get an Arduino, and then you get a breadboard. The breadboard itself now is really, really interesting. It was really useful because if you've got an idea, I want to make a flashing light, or I want to make this light turn on and off, you can do your little bit of code, which you might be going, ooh, scary. But there's so many examples online that you can, and it's not too bad. You can then prototype yourself up onto the breadboard and test things. Try your resistors out till you get the right with the voltage that you're running. So the light's not too bright or it's not too dim. It's like, oh, that seems about right. And you get that right, and then you know that when I go and solder it up, I don't have to solder that one on, then desolder it and add another one on, and it gets a bit annoying, or try and hold them together to get the power and things. You just put them in, they can sit there, and you can tinker away and try different ways of making things work along the way. And the wires for the breadboard are these little things with these little pins on that basically just push in. And another useful thing that I've also got is there's a little power board for when you need a bit more power if you're prototyping with servos and things, because they take a little bit more power than what the Arduino actually puts out. But you can run your lights straight off the Arduino without an external power. So what really is a breadboard, and what does it involve? Well, the breadboard is one of the things that is really useful to have with your Arduino when you're starting out, because you'll probably go through a bunch of online videos and how to flash a light, how to drive a motor, how to do some simple little things just so you get familiar with it. And the breadboards are really useful for this because you can pin them on and follow the little diagrams you get online called fritzing diagrams, and it shows you what you're doing. So basically the red and pink line, the reddy pink line, and the blue line is for positive. So all the way down that strip is positive, but things go right to left in a straight line across the board. So A30 goes all the way up and across, sort of thing. And the blue is your negative power. So if you were to put an LED in there, you might put it into, say, A1 and A2, and then run a positive and a negative into B1 and B2. So you get that little loop across there, like we have here. So we've got our ground coming out, which is our blue at the bottom here, and that goes into our ground one on this board, because it's the other way around on the colors. You get different colors, and they normally have a plus and a minus at the other end as long as you run them the same way around. And you see how the LEDs are put in there across instead of up like the resistors are. The resistors are the little brown things in the middle, and some jump wires, etc., going up and across and back. And the 3 LEDs are in the board here. And with this little circuit here, this is one of the learning circuits that I'll put through in my documentation for you all if you're interested. Basically what it does is it just loops through and will turn on the green. It's basically simulating a traffic signal, so the green will stay on for a little bit, and then it'll go orange, and then red, and then the red will stay on for a little bit, then it'll go back to green, and then loop back through. So you get a time delay in between, like the traffic light, like driving through traffic lights, which is quite cool. And when you get it running on the breadboard and you look at it for the first time, you go, "Whoa, that's pretty cool. I made that happen." You've looked at this little computer program, you've sort of gone, I don't really understand 100% what it's doing, but I can sort of work it out. I've uploaded it via the USB from my computer into this little microcontroller. This microcontroller is now controlling these lights, and it's going, etc. So the Arduino IDE. So this is something that I'm going to touch on briefly. It's something that you need to be comfortable with. Don't be too scared of it. And basically, it's the development environment, which is cross-platform application that is written in functions from C and C++. It's used to write and upload programs to Arduino compatible boards, etc. So we're well into, if basically, just don't be scared by it. If you can take a photo on your phone these days, most people can, you can get that photo back onto your computer somehow by emailing it, sending it to yourself, and then you can attach it to an email, or you can post it up into Facebook, etc. If you can do that, then you should be able, you more than likely can use the IDE, which is an open source. It's free, the program. You download it, you put it on your computer, and away you go. You set your board up, etc. And away you go. So there's a few rules, but I'll put some links into some nice trainings on how to use that and how to get yourself started with an Uno, because I'd suggest you get an Uno first, because that's nice and common and easy, and it detects a lot of the time which board that you've actually plugged into your computer when you turn the IDE on, and you can download lots of examples of code and load them into there, and then work out the diagram and do the wiring part, and not worry too much about the code when you're first starting, because there's a lot of help, a lot of videos out there on this stuff as well. If you're curious about, and if you're really curious about the world of Arduinos and model trains, it's not a big investment to have a tinker. It's not like you're going to outlay, like when you buy your first DCC system, did I buy the right one? Am I buying the right one? Because I've got to outlay $300 to $500 on my DCC system. It's a minimal outlay of the price of a carriage, of a decent carriage, $30 to $50 initial investment, etc., which is very minimal. And I'd say take the plunge. If you're curious, take the plunge. Have a go. Give it a go. Don't be scared to give it a go. And that's it.
Thank you very much, Michael. There's a few questions. When do you use Arduino versus a Raspberry Pi? And we don't have a lot of time, so I know you showed the DCC++ system that uses both. But when do you go Arduino? When do you go Raspberry Pi?
I can't hear you, Speed. You got your microphone down?
Any better?
Can you hear me?
Can you hear me, Michael?
Okay.
Michael, can you hear us?
It's Michael's end. Michael, can you hear me? It's Gordy.
Can't hear any of us.
I've lost everyone at the minute. I haven't muted myself, have I?
Can you see us? Do you have a visual? Can you see? Can you hear?
Yeah, you can see us. Can you hear us?
No.
Yeah.
Okay, so how about we ask him to answer the
No
question
hearing.
in the YouTube feed? Cordy, can you hear me?
Yeah. Yeah. Yeah, I can hear you. Hey, tell everyone. You can see we're having a few problems today.
Just a few.
Sorry for everybody who was trying to listen to us in the on Facebook there, and Facebook decided to lose its pants. So we won't be going back to Facebook for the rest of today. We'll be staying on YouTube. So please tell your friends to come find us on YouTube using this link. Sorry that the title's wrong, but that's what happens when you fire something off in 5 minutes. What we're going to just do is we're going to unfortunately not be able to ask Mike questions directly because something at Mike's end is not going so great today, and I'm going to make an attempt to transition over to something that hopefully isn't a blank screen. So